Welcome. In this video, we're going to look at an example on how to use the three equations of motion. Okay, so the question says, a man starts from rest and attains an acceleration of 2 meters per second squared in 5 seconds. So we are told to say starts from rest, meaning there's no movement there. It was just from rest. There was no velocity. The initial velocity was 0. And attains an acceleration of 2 meters per second squared in 5 seconds. So let's come up with the data. So data, initial velocity, which is u, is equal to 0 from rest. It means the initial velocity is 0. And attains an acceleration of 2 meters per second squared. So a is equal to 2 meters per second squared. And the other thing that we've been given there is time, which is 5 seconds. Now we are going to say calculate the final velocity and the distance covered in 5 seconds. Okay, so here we do not have the final velocity and we do not have the distance. Now what we do, we have the three equations of motion, which is the first one is v is equal to u plus at. The second one is x is equal to ut plus half at squared, and the third one is v squared is equal to u squared plus 2ax. Now, whenever we are calculating any of these variables, what we need to do is we need to be guided by the information that we've been given. So in this case, we've been given the information u we've been given, a we've been given, and t we've been given. What we don't have, in order for us to find the final velocity is what we don't have is simply the final velocity in the first part. So what we're going to do is we are going to make use of the first equation. Since we have u, we have a, we have t. So we are going to have solutions for part 1. V is equal to u plus a t. Our u there, we just plug in the values. That is 0 plus our a is 2 times our time is 5. What we're going to have is 10, and the units are meters per second, the meters for velocity. So that is an answer for the first part. Now let's look at the second part. Let's look at the second part. Okay, we are told to find the distance. So distance, which formula connects speed, time, and distance, or which formula can we use among these? We have v is equal to u plus at, and obviously we cannot use this because we don't have distance. What about the second one? X is equal to ut plus half at squared. So we have been given u, t, a, and that is squared. Yeah, it is just t. We've been given t. So that one can work. And this one, we have b squared. We have found our b squared to be 10 and u squared, that is 0, and we have a, then yes, we have a, so this one can also work. So what we're going to do is we're going to make use of the second equation. We're going to make use of these two equations in order for us to find that. So let us begin with our second equation, which is u t plus half at squared. Okay, so we've been given u, which is 0, so 0 times t, our t is 5, plus half, our a is 2, times our time, it is 5 squared. So what we're going to have is x is equal to 0 plus 1 over 2 times 2 times 5 times 5. So this and this are going to cancel. What we're going to have is x is equal to 5 times 5. And what we're going to have here is 25 meters. Those are the units for distance. And let us try to look at method number 2. Method number 2 using the third equation. So we have, okay, so let's just simply say O, so v squared is equal to u squared plus 2ax. Okay, so now from here, let's plug in the values. We found our v to be 10, so 10 squared. which is equal to, our u is 0, so 0 squared plus 2 times the value for acceleration is 2, then times x. What we're going to have is here 10 squared is simply 10 times 10, which is 100, which is equal to 0 squared is simply 0, and what we're going to have is 4x. So if we want to have x, we just divide by 4, and here we divide by 4. So this and this are going to cancel. What we're going to have is x is equal to 25. What are the units for distance? We have